Okay, so let's read the question. The question says we have been given a zero index array of n integers of differences. So we have been given the integers array of differences. For example, in this example, which is 1 minus 3 and 4, right? So that means this one difference is and this says this is difference of the next number, right? So this number, so for example, this is one of the number, so this becomes n1 and n2. So this number is a difference of the n2 minus n1, right? And this number is the difference of the n3 minus n2, right? And this number is the difference of the n4 minus n3. So by looking at this question, you understand two things, right? So if there are n differences, then there is going to be n plus 1 numbers, right? So let's take, and they have also given us the two limits, which is lower limit and upper limit. In this example, which is this one, we have been given two limits, right? Which is lower is 1 and upper is 6, right? So now we have to find all the numbers which lies between 1 and 6, right? So if you look at this, right, there's one, if you have to find all the numbers, right, so what you do is you start with the lower number, right, which is 1, and the upper number is 6. So you start with that and tries to find all the numbers starting from 1. So starting with number 1, next number will be 2 because the difference is 2. Then to find the next number, we have to add this next number, and that becomes minus 1. So if you see, minus 1 and minus 2 becomes minus 3. And then we find the next number, which is 3. So this is one sequence, right? But if you see in this, we have this number which is going out of range, which is less than 1, right? So this can't be the sequence, right? So similarly, we try the next number which lies between 1 to 1 and 6. So we try with the 2, and this goes 3, and this becomes 0, and this becomes 4, right? In this again, you will see this 0 is going out of range, so this can't be the sequence. But if we try this 3 number, and then next number becomes 4, and then next number becomes 1, and the next number becomes 5. So in this, all of these numbers fall in the range. So this is one of the possible sequence, this is one of the sequence, right? Similarly, if we try with 4, then 5, then 2, and then this becomes 6. Again, all of these numbers lies within the range, which is lower and upper. So this is good, right? And similarly, we can try with 5, right? And 6, right? And then 3, and then 7. Then you will see here this is going out of range, right? So this can't be the one. And similarly, we can try with the 6, which is 7. Then again, this 7 is going out of the range, right? And then 4, and then 8. So these two are going out of the range, so this can't be the sequence. So we see we tried all the numbers which lied between one given range, which is lower and 6, lower and upper, right? After this, we found two possible sequences, which are valid possible sequences. So answer becomes 2. Now, so this is a brute force approach, right, where we are trying all the possible numbers which lies between 1 and 6, right? And for each number, we need to generate a sequence and check whether they lie between that range or not, right? So this becomes big O of n square complexity. But if you look at this question, which is leet code 2145, the range is 10 to the power 5. So this solution won't work. So what we have to do is, now let's try to optimize this. So what you will see is, when we are forming these sequences, we are basically adding these numbers, right? So for that, if you look carefully, so for example, I'm trying this x number, right? And in this, I'm adding difference 0, right? And then, so this is how I get my first number, right? And then, so for example, this one is n1, x plus difference of 0. Then for n2, you will see what I'm going to do is difference of 0 plus difference of 1, and then I get my second number, which is this one, right? And then for the third number, what I'm going to do is x plus difference of 0 plus difference of 1 plus difference of 2, right? So I get the third number. And if you see so on, if I have to find the ith number, what I have to do is I have to do the sum of all of these numbers which lies between 0 to I, right? Difference of 0, difference of 1, and so on, and then I can get the ith number, right? So in this way we can always find all of these numbers, right? Which is n1, n1, n2, and ni, right? Now if you notice, we are every time we are adding the next number, and you will recognize this is called prefix sum, right? So to find all of these numbers we can use the prefix sum. Now what you will see is, if we calculate the prefix sum, right, which is sum of all of these numbers for each number, and in this, for example, prefix sum of prefix sum 1, prefix sum 2, prefix sum 3, and prefix sum I, right? Now what you will see is, if in this we find the minimum of prefix sum, right, prefix sum, minimum value in this, right, minimum of prefix sum, right, and then I have max, if I find the maximum of prefix sum, right, prefix underscore sum, right, then if I add this value, which is minimum of prefix sum, and then if I add maximum prefix sum, they must lie between my lower range, which is lower less than or equals to this, and then my x plus max of upper, right? This needs to be happen, then and only our sequence is called valid. So if you look at this example, let me just calculate the prefix sum for this 1 minus 3 and 4, right? So if I calculate 1 minus 2, and then if I add 4, this becomes 2. So minimum, it becomes minus 2, and maximum becomes 2, right? So now in this, since my original number were my lower limit was lower limit was 3 and upper limit was 6, right? So if I add each of these numbers, my original numbers were 1 minus 3 and 4, if I add these, right, so they has to lie between 3 and 6, right, from this formula, or when we are calculating the sequence, right, then and only I can say it's a valid sequence, right? So now we can rearrange this formula now. So I have lower less than or is equals to x plus minimum of prefix sum, right, and I have x plus max of prefix sum. This has to be less than or equals to upper, right? So I can say lower minus minimum of prefix sum, it has to be less than or equals to x, and this has to be less than or, because I'm transferring this to here and this to here, up, and so upper minus max of prefix sum. This becomes my new formula. Now for all the values which are between lower and upper range which was given to me, if I check all of these values, if they lie between these two, right, which is this becomes my new lower limit, which is lower minus minimum of prefix sum, and new upper limit becomes, which is upper minus max prefix sum, right? So now if I can find all the numbers which lies between these two, then that becomes my answer, right? Now so let's just say, and let's take this example, which was in the existing example, right, we had this differences array which is minus 1 minus 3 and 4, right. My existing lower limit was 3 and upper was 6, right. So what I do is, which is, let me draw this on number line, right. So I have this is 3 and then 6, right. And then my new lower becomes, which was new lower becomes 3 minus 2, which is 1, right. So new lower becomes new lower becomes 1, right. And then upper becomes, and upper becomes 6 minus max, right, which is 2, which is 4, right. Max was 2, right. So new becomes 4. Now now to find the common numbers, right, I can just take the maximum of this and minimum of this, which is 3 and 4. And if I do minus of these two, which is 4 minus 3 plus 1, this will give me a final answer, which is 2. This is my valid answer, right.